Hi, hello, welcome to VHL Basics. Today we are going to design a edge detector using FSM state machine. In VLSI design, a signal edge detector is a module that detects the transition or edges in digital signal. Digital signals transition between high and low states, and detecting this transition accurately is important in many applications such as timing, synchronization, data sampling, and signal processing. A basic edge detector typically consists of flip-flop, combinational logic gates, and sometimes sequential logic element like shift register. The detector monitors the input signal and generates an output signal indicating when a transition occurs. The application of signal edge detection in VLSI. Clock synchronization. In synchronous digital circuit, accurate detection of clock edges is crucial for timing synchronization. Signal edge detection. Detectors are used to identifying the rising or falling edge of the clock signal, ensuring that other circuit element latch data at the correct timing. Data sampling. In data acquisition system or communication interfaces, incoming data streams need to be sampled at specific times to capture the information accurately. Edge detectors help the identifying the timing of data transition, enabling the precise sampling. Serial communication. In serial communication, protocol like UART and or SPI signal edge detection is used to synchronize the data transmission and reception between devices. It helps in framing data packets and detecting the start and end of the each transmission. Memory interfaces. In memory interfaces such as DDR and SDRAM, signal edge detectors plays a crucial role in synchronizing data transfers between the memory controller and memory modules. They ensure that data is sampled at the correct clock edge to maintain the data integrity and reliability. Event detection. In digital signal processing application, signal edge detectors are used to detect the specific events or conditions in the input signal. For example, in audio processing, edge detection can be used to identifying the onset or offset of the sound signal. Power management. Signal edge detection can be employed in power management circuit to monitor changes in power supply voltages or currents. Detecting voltage or current spikes can trigger actions such as voltage regulation or power gating to optimize the power optimization consumption. And debugging. During VLSI chip testing and debugging, the signal edge detector circuit are often utilized to monitor the internal signals and detect abnormal app behavior or timing violation. This helps in identifying and diagnosing potential issue in the design. Overall, signal edge detection is fundamental technique in VLSI design, enabling accurate timing synchronization, data processing, communication, and system monitoring in various applications. So this is the state mission to detect the edge in the digital signals. So initially the state will be in ideal state. If input signal is in low, right, then it will go to rising edge detector state. If the once the reset is selected, the input signal value is 1 means that time it will go to the falling edge state. So in rising edge state, it will wait for signal to go high. When signal is going high, that time it will move to the falling edge state, and the output edge detect will be set as 1 actually. Likewise, if we are seeing the value input signal value is 0 means it will stay in the same rising edge detect state. In falling edge detect state, if it detects high in the input signal, right, then it will stay in the same falling edge detect state, and output will be assigned to 0. Once the falling edge detect state is detecting the input value to 0 means at that time it will move to the rising edge stage and with output value as 1. So this is the state machine which we are going to design in the Verilog now. So this is the falling edge detector module using state machine. So like we discussed, we have one clock reset and data in signal, and edge out is the output of this particular module. Here we have three states. Those three states we are declaring as a parameter: ideal, rising edge, and falling edge. And then we are declaring the state and next state, and we are having one more a register called edge underscore o. Here if you see every passage of the clock, a state will be assigned to the next state will be assigned to state, and output edge out will get the value from edge out underscore 0 underscore o. Now moving to the state machine. Here if you see if state is ideal, so once reset is released, state will be in ideal state. Here we will check the input value. If it is 0, it will go to the rising edge, and if it is 1, it will go to the falling edge. In rising edge, it will detect it will wait to detect high in the input signal. If it is detected that high in the input signal, then we will set this edge underscore o to 1, and the state machine will move to the falling edge state. Otherwise it will stay in the same rising edge state, and edge out will be 0. In falling edge, once data in is 0, right, it will move to the rising edge state. Otherwise it will stay in the same falling edge state. When it is moving to the rising edge state, at that time the edge underscore o will be 1. So now I will show you the simulation test bench. So this is the test bench for edge detector, where all the input I am declaring as a register, and output edge out I am declaring as a wire. And here I am generating the clock. I think 200 megahertz I am generating, and I am toggling the reset, and then I am toggling the data in here. So I will show you the and I am instantiating the edge detector module here. Now I will show you the waveform with respect to this. If you see here, once reset is going low, we will shift the state with respect to the input value. If you see input is 0, so it is moving to the rising edge state, and here it is waiting for signal to go high. Once signal is as data in is going high, that time edge out will be set as 1, and then state will move to the falling edge. That's what happening. So likewise it will detect all the edges in the data in digital signal. Hope this will be useful for your design. Please like, share, and subscribe this channel for more videos. Thanks for watching this video.